Hello friends, this video on solid states part 27 is brought to you by examfear.com. No more fear from exam. Right. Let's take one more numerical now. Copper crystallized into FCC lattice. First draw the FCC lattice with the edge length 3.61 10 to the power minus 8 centimeter. We have to show that the density is in arrangement with its measured value of 8.92 gram per centimeter. So we have to prove the density is this value. So let's see this. Density is what? Zm by A cube Na. What is the value of Z? So here Z is equal to 4. M is equal to molar mass of copper we know is 63.5 actually. Grams per mole, and this is 4 atom, divided by A cube. A cube is given 3.61 into 10 to the power minus 8 centimeter whole cube. Na is what? Na is 6.022 into 10 to the power 23 atoms per mole. This gets cancelled, atom gets cancelled. What you get is 8.92 and unit will be gram per centimeter. Correct? The next question is nickel analysis shows that nickel oxide has a formula Ni 0.9801. What fraction of nickel exists as Ni2 plus and Ni3 plus? So here we have a nickel which has Ni2 plus and Ni3 plus also. So we have to find how many fractions has Ni2 plus and how many has Ni3 plus. So let's assume there are 100 oxygen atoms. Okay. So let's assume there are 100 oxygen atoms. So with this, I'll try to find the number of Ni2 plus and Ni3 plus. Correct. Now, if that is the case, if you have 100 oxygen atom, how many nickel atom will be there? Obviously, then nickel will be how much? 0.98 into 100, that is 98. So nickel will be 98. And this nickel is nothing but both Ni2 plus and Ni3 plus. Correct? And let's assume this Ni2 plus is X. So Ni3 plus will be how much? 98 minus X. Correct? Because the whole nickel is 98 atoms. So Ni2 plus is X, then Ni3 plus will be obviously 98 minus X. Okay. Now the net charge has to be 0, right? So net charge is 0. So net charge is 0, that means net charge of nickel will be equal to net charge of oxygen. Correct? Because oxygen has -2 charge each oxygen atom and nickel has +2 and +3, but since it is neutral, so net charge has to be 0, and net charge has to be 0, that means the net charge of nickel has to be equal to net charge of oxygen. So net charge of nickel will be what? If there are X number of 2 plus nickel, then we'll get 2x charge from this, and 98 minus X of 3 plus nickel, then I'll get 3 into 98 minus X. Correct? 2 into X, 3 into 98 minus X. And this total will be how much? There will be the net charge of oxygen. How much is oxygen? There are 100 oxygen atom and each oxygen has how much? 2 charge. Correct? So if you solve this, you get X as 94. That means by Ni2 plus there are 94 atoms and Ni3 plus is 98 minus X is how much? 4. So Ni3 plus is 4. This is the number of atoms given oxygen is 100. Let us assume. So you want to find the percentage of Ni2 plus will be how much? That is percentage of Ni2 plus will be the number of Ni2 plus, that is 94, divided by total number of nickel, that is 98. We know, right? 98 into 100 that is nothing but 96%. So 96% I have Ni2 plus. So obviously Ni3 plus will be how much? 100 minus 96, that is 4%. If you want, you can also get this value by 4 by 98 into 100. So almost 4%. That is also one way of getting it. Correct? And this is my nickel. So if you see, some are plus 2 and some are plus 3. The next question is, non-stoichiometric cuprous oxide Cu2O can be prepared in the lab. In this oxide, copper to oxygen ratio is slightly less than 2:1. That is, copper is almost, if you say assume less than 2, that is, you can say it is 1.9 or something, or 1.95, slightly less than 2. What can you account for the fact that this is a p-type semiconductor? See, Cu2O, right? So atomic now, the charge on copper is plus 1 here, because oxygen is minus 2. So charge is on the copper is plus 1. Plus 1 into 2 is plus 2 and minus 2 is neutral. So copper is plus 1 here. But since here the concentration of copper is less than 2, that means what is happening is there are some copper plus 2. There are some copper plus 2 which is displacing this copper 1, correct? And that's why density of copper is going down. It's a metal deficit defect actually, right? So the copper density, the copper number concentration is going down. That means there is some Cu plus 2 which is removing this copper, and there is some vacancy created, correct? This is exactly what I'm talking about. I mean, assuming this is my copper, this purple is my copper. Let's suppose this is my copper plus 1. That means there are some copper plus 2, this copper plus 2, which is removing 2 copper plus 1 and it's creating 1 deficiency. Here also this copper 2 plus has kicked out 2 Cu plus 1. It occupied one's position and other is vacant, correct? So for every every 1 Cu2 plus will replace 2 Cu plus 1, correct? Now since they are holes, that means the conduction will arise, right? So conduction will happen now because of positive holes, correct? Since we have positive holes here, it is p-type current, correct? With that we can say that yes, actually it is a p-type semicurrent. The next is, ferric oxide crystallizes in a hexagonal closed packed array of oxides ion with 2 out of every 3 octahedral holes occupied by ferric ions. Derive the formula of ferric oxide. So it is saying that 2/3 of octahedral holes is occupied by ferric ion, right? Ferric ion. And oxygen will obviously occupying the lattice. So if oxygen is X number of oxygen we have, so ferric is how much? 2/3 of X, because octahedral hole is nothing but is equal to number of atoms X, and we are talking about 2/3 of the octahedral holes. Had it been tetrahedral hole, it will be 2/3 of 2X, right? So octahedral hole, that is nothing but equal to number of atoms in the lattice. So if you talk about iron and oxygen ratio, that is nothing but 2/3X, because iron is 2/3X and oxygen is X. That is nothing but 2:3. So the formula will be Fe actually, Fe3 sorry, Fe2O3. Why? Because iron is 2, oxygen is 3, right? The ratio of iron is to oxygen is 2:3.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.